Hello and welcome to today's Quick Start. My name is Yannick and I will show you how to configure the new CMMT Magnetic Field and Temperature Sensor via TAS and with a TBNN device. Basically, you can use any I/O link master you want, but if you use a Turck I/O link master, you have the advantage of the magnetic field monitor. I will show you in a second how comfortable it is with this monitor. So let's take an CMMT on factory defaults. I will now unbox it. The TBN is already up and running. And as soon as I connect the sensor, the TBN recognizes there is an I/O link device connected. So the next thing we will do is start the TAS, the Turck Automation Suite. So, and basically here you can scan for each device in the network. I will do this right now. And as you can see, there's one TBN connected currently. If you don't know which TBN you have, if you connected several ones, you have always this blink function, which shows the exact device you are connected to. So, and from here we can directly enter the environment of the TBN, but just some information before. As you can see here, I have the devices in the same IP subnet, so that's necessary to connect. Let me quickly change to English. In case you didn't know, it's quite easy to change the language in TAS. And yeah, now we will directly connect to the TBN, and I will take the TAS environment. We also have a web browser or a web server of the TBN, but I will take the TAS environment. And I don't want to switch any configuration of the TBN, just change the sensor settings. And with a click on I/O link, we would see all devices connected to the TBN, but it is password protected. And as soon as we have logged into the device, so you can see there's currently one sensor connected on port 1 of the TBN, so that's correct. It has loaded a generic IODD, so there are now two ways you can proceed. Either you load an IODD directly from the PC, if you have it on the hard drive, or we can use the web search so that the program will take the IODD finder to get the information. And as you've seen here, with one click it's done. So now we have directly access to the sensor with full functionality. So we can directly jump into the magnetic field monitor, and what we basically see now is the magnetic environment of the sensor across all 3 axes, as well as the sum vector. And this is the Earth magnetic field you see, and how it behaves with all the materials here around. So we have some metals and so on that influence the magnetic field around here. And if I now take a basic magnet and put it near the sensor, we you can see for each axis the changes in the magnetic field. And you could proceed from here, but it's better to zero down all axes to ignore the magnetic environment that is already existing. I will quickly show you how to do this. When you click on parameters, you have this button that uses a command to the sensor. It's called zero offset calibration. And as soon as it's loaded with one click on it, the sensor is now proceeding a zero offset. And as you can see here, all axes are now zeroed, and look at here, I also ignore the magnet that's placed beside the sensor. If I put it away, you can see changes in the magnetic field, because now it's different, because the magnet is not in the near anymore. And but what we want to do is we want to make a switching window for one output to detect this magnet with the right orientation. I will quickly zero offset it again, so that we have the zero offset without the magnet in the near. A quick look. Yeah, you can see here some micro Tesla variations, but this is normal if there's no target near. And as you can see here, we have some micro Tesla on the Z-axis, which is through the sensor when I get closer with the magnet. Okay, so I will place the magnet along the x-axis, and yeah, as you can see here, the x-axis is the red one. We have values of about 100, 150, and I will take that for the switching window. And now we go to parameters, and here you can select the output behavior. So the first output is selected for the magnitude, for the sum vector of all axes, and then I will take output 2 and use the x-axis as this is the axis that is right now affected from the magnet. And yeah, what you can see here are different channels. So each axis and the sum vector are assigned to a channel. And dot 1 is always for output 1 and dot 2 for output 2. So I will scroll down until I see the x-axis and output 2. So this is the one I want to yeah, make a switching window for. So I don't want to take the 2-point mode, which is basically a set point and a reset point. I want to take the window mode. And yeah, as we have seen the values before, I would say we take 100 microtesla up to 300 microtesla. This will be our switching window. Don't want to change any other parameters such as on and off delays. So the next thing I have to do is to write these changes into the sensor. And let's now take a look to the magnetic field monitor. I will disable all the other axes so that we can only focus on the x-axis. So and if I take the magnet away, as you can see here, we still have the 0 offset calibration. So it's 0 when no target is near. And we'll now get closer with the sensor. And as you can see here, we get values below 0. So that means the magnet basically wrong orientated. And I change it, you have a peak on the other side, and as soon as I'm above 100, output 2 LED is showing. And if I get closer to the sensor, the value is increasing, and as soon as we are above 300, we are out of the switching window, so the LED switches off again. So we can use this either for orientation control of a magnet, or to differentiate between different magnets. As you can see here, I have a far stronger magnet. And yeah, if I put it on the same distance to the sensor, we have a far higher value, as you can see here. And yeah, so we can differentiate between different magnets. So this is how to set up the sensor. There are two more things, I would say. If we look at the parameters and scroll down, you can see the switching counters. And yeah, what we have actually changed are the parameters for the x-axis. This is no live screen right now. So whatever I do now, I have to refresh the page again. You can do this by clicking on read. And as you have seen now, the values have changed. And yeah, one other thing I wanted to show you, the process data. So if you use any other I/O link master and do not have access to the magnetic field monitor, you can basically see all the information shown here on the screen for each axis or for each channel, as I said before. That can also help to determine a switching window. And yeah, that is basically how to configure the sensor via TAS and I/O link. Thank you very much for watching, and see you next time.